That's funny.
That's our band. We threw those shirts out on Saturday for our concert.
All right. What do you play?
I play bass.
Oh, really? That's cool. Very nice. I'm an aspiring drummer. I claim no greatness, but I like to dabble. So, that's cool. Todd. So is it named after the principal?
Yeah.
Funny.
Oh. I didn't know.
You didn't know?
I did not know.
Which one?
The Todd father. That's funny. All right. All right, moving on. Okay. Now it's on the video and everything. Whatever. Okay. Now I'm going to get fired. Okay. They threatened to fire me. Please put in a vote of support. Okay. Not for firing, you know. I actually do like this job a lot. So. I'm not quite ready for a third career. This is my second one. So. Here we go. Okay, this has nothing to do with infinity. This just says find the limit. And in fact, it says use limits to analyze the continuity. So the wording is identical to all of the problems that you all finished in the buff packet. Use limits to analyze the continuity. We're going to take a little bit of a shortcut. In the buff packet, you would have written the limit as x approaches positive. Like you would have written this to start with. So go ahead and write this down. You would have said find the limit as x gets close to -4 from the left. That's how you would have begun the problem in the buff packet. So write that on this one as well, because the instructions are the same. However, if you're not looking at a graph or a piecewise function, that's what the buff packet was, graphs and piecewise functions, then you can be a little bit quicker and you can do the left and right at the same time, usually. Like we'll hit an exception later in the year and I'll say, okay, here's an exception, but about 99% of the time, you can do left and right together. So put a plus right there to indicate that you're going to do both. Another thing I got to warn you about, that's actually not legal notation. So I'm going to have you use it for a few days until I convince you that we really are doing both, and then we'll stop writing it. But we're doing both, and we're doing it for f. So let's put an f of x there. We're just finding the limit of left and right of f of x as x gets close to -4. Questions? This should feel identical to the buff packet so far. You're just finding a limit. We have some new guidelines here. We cannot do step 1 because we don't have a limit as x grows forever. So you notice that there's a step 1, but you can't use it. Question? Cool. Next step says to factor and divide. That's new. We've not done that before. Key symbol there is and. It's not factor and maybe divide. It's like factor and divide. Meaning if you can't divide, there's no reason to factor. So looking at this, I kind of think, hey, those look like pretty simple quadratics. So let's go ahead and factor them. And we're doing the left and right limits simultaneously here. So we're going to factor. So you got an x, another x. 32, 8, and 4 looks good. Pause for questions so far. I'll put in the plus and minus here in a minute. And let's see, the negative 4x means the 8's got to be negative and the 4 is positive. And then the bottom will factor as well, like so. Questions from anyone? Bothered by any of that? Yeah, please, Laura.
Sorry, going back to the 4 from the right and the left, would that just be the overall limit?
Yes. The key thing, the reason I'm writing the plus and the minus, is it's just been common for students, if I don't write that, to think we're actually just using -4. And we're not. We're finding the left and the right because the only way to find the overall limit is to find the left and the right. Good question. 2 more. Awesome. Okay. We factored so that we could divide. So write one more line on your paper here. x approaching -4. We're considering what happens when x gets close to -4, both from the left and the right. And we have this formula now. Now these are factored. We can write them out separately. Questions from anyone? Cool. Okay, as x gets closer and closer to -4, remember x will not equal -4 in this analysis, but as x becomes very, very close to -4, raise your hand if you know what will the value of the yellow box become. So as x gets closer and closer to equaling -4, either a little more or a little less, what will be the value of the yellow box? Everybody here? If your hand is raised, you give yourself 2. We'll try Sewell Page. Is it Sewell Page, is that right?
Yeah.
Okay. So Sewell says this is equal to 1. He is absolutely correct. He gets 3 points, 2 points if you raise your hand. In fact, this yellow box, it doesn't matter what value you pick for x. Please memorize that. You can pick any value you want. The yellow box is 1. Unless x has an exact value of -4. If x were exactly -4, that yellow box is undefined. Because you would have -4 plus 4 divided by the same, which would be exactly 0 divided by 0, which no one knows what that equals. So unless x is exactly -4, the yellow box is 1. That's going to happen over and over again all year. Make sure it makes sense. Make sure you memorize it. Questions? Awesome. Okay, so finding the limit now becomes pretty easy. Because, let's see, raise your hand please. Everybody. What's the purple going to equal when x is almost -4? Because x is not going to equal -4, but x is going to get very, very close to -4. What's the purple box when x is almost -4? Whether a little more than -4 or a little less. What's the purple? So is the purple thing going to equal? Hands up. Good for a couple more. Pretty good. Let's go Jason Riley.
Like around -12.
He's sorry to interrupt you. I apologize. He said it really well. Like the word that got me excited was he said around. The purple's not going to equal -12, but as long as we're close to -4, either a little more, or a little less, that's going to be really close to -12. So this is close. Well, let's don't do it that way. Let's go like this. We were finding x-y pairs. So if your hand was raised, point. Jace gets 3 for that one. And we plugged in close to -4, like a little less. And we plugged in a little bit more than -4. We're getting not exactly, but we are getting close to -12 on the top. We're not getting exactly, but we are getting close to -12 on the top. Anyone bothered by that? Oh, please, Ava. So, are you okay, Ava, that if x is almost -4, either a little more or a little less, the yellow box will be precisely equal to 1? Awesome. So that means if we replace this x with a value that's almost -4, what's -4 minus 8? 12, -12. But we're not plugging in exactly -4, we're just plugging in close. So that means that close to -4 minus 8 would be close to -12. Did that answer your question? 2 more. Cool. How about the bottom? Hands up. What's the bottom going to be when x is almost -4? What's the bottom going to be? Let's go, Jack.
About -8.
About -8. Thank you for saying about. Point if your hand was raised. 2 for Jack. That's it. You can leave it like that if you want. You can reduce it if you want. We have found the limit. As x becomes closer and closer to -4, either a little more or a little less, the limit is exactly -12 over -8. We have analyzed the limit. So Questions? Solid. We haven't finished analyzing the continuity. Who remembers from the buff packet, hands up, what else we must write down in order to finish our analysis of the continuity? Hands, everybody. We have done the left-right limit, and as Laura said, we've found the overall limit by finding the left and the right, because the overall is just a comparison. So point if your hand is raised. Gemma, what's the next thing we got to do?
F of -4.
Nicely done. So Gemma gets some extra points here. So we've got f of -4. Do we know what that's going to equal, Gemma, when x is exactly -4?
You just plug it into the first equation.
So stay with me. We could plug it into the green. And this goes back to what we talked about before, Henry's question, I believe. We have the green formula. We have the blue. We have this, we'll say red. Are those formulas all the same, or are they different like last time, Gemma?
They're different.
So they look different, but they actually are the same in this case.
Okay.
Because we didn't throw anything away. We just factored and kind of rearranged. So green, blue, and red are all the same. So we could plug a -4 into the green, blue, or red. We would get the same answer in all three. 3 points for Gemma. However, red is easiest. If I put a -4 into the red formula, what's the result? Hands, everybody. I put a -4 into that red formula. What's the result, Rebecca? Yeah, like we talked here, the yellow box becomes undefined. Undefined multiplied by whatever is still undefined. So this is undefined. Point if your hand was raised, 2 for Rebecca. Questions? Oh, please, Julia.
Where we put the equal -12 over -8, is that just for the second portion of the red box?
No, it's the whole red box.
So it's,
It-
the red box isn't undefined, but the,
Let me say it back to you. That -3 points for Julia, that -12 over -8 is actually equal to this entire, let's change color, this entire brown box. That's what the -12 over -8 is equal to. Because it's saying, what's the value of this formula when x becomes very, very close to -4? When x is very, very close to -4, the yellow is 1.
oh, okay.
Did that help
Yeah.
a little bit? Yeah. And then when we went to f of -4, we're still using this box. Your question's really good. I can see why it can be confusing. We're no longer thinking of the limit.
Yeah.
Does that help?
Yeah.
It's good work. Anybody else? The conclusion then is something like this. Some space. So the conclusion is, therefore, I don't think that's how you spell duh. F of x has removable discontinuity at x equal -4 because, abbreviate that, the limit overall as x approaches -4 of f is not equal to f of -4. Question. That completes the analysis of the continuity. So, please, up here, sir.
I'm just saying, you just wrote it as equals, I'm guessing you meant to put a slash.
Oh, thank you. My bad. 3 points for Wyatt. Shoot, Pierce. Wyatt's your brother, yeah?
Yeah.
Please.
So with a question that has like x equals -4, we need to have like 5 answers, like the green line, the blue line, the brown, the red, and then the negative 4 statement?
Oh, gotcha.
Or how many like are you expecting us to write?
Outstanding. You can skip the green if you want. I did that just to, hopefully for clarity, like you can follow what I'm thinking. But you don't have to write the green.
Okay.
I would say the blue is required. I think the problem is nearly impossible to solve without writing it. You could skip the brown though and just put equal -12 over -8 here. So you wouldn't have to have any of that. You do have to have this statement here and then the conclusion. So the most concise version of the problem would simply require this line, and the conclusion. Is that your question, Kate? Good work. 2 more, please.
Sorry, how did you get to removable discontinuity?
Oh, that one just came from your flashcard
Okay.
that we made for the buff packet, so a couple of days ago, a couple of class periods ago, where the flashcard says if the value of a limit as x gets close to some number is, so that means the overall limit exists because the left and right are the same. If that's not the same as the function's value, they just gave that a name. They called it a removable discontinuity. If you were looking at a graph of this, Annalisa, we'd be here at x equal -4. Dotted lines are not easy to draw with this pen. And what we find is we have a y coordinate of about 3/2 here and also here when we're really close to x equal -4. But right at x equal -4, we don't have a value at all. So that's a removable discount. That help?
Yeah.
3 more. Yeah, please.
Yeah, I just want to make sure I understand. So f of -4 is undefined because when you plug in -4 to the bottom of that brown box that you've circled on the board, you get 0, and anything divided by 0 is undefined.
Perfect.
That way.
Mhm.
Okay.
Nope.
And even though it's split up, when you plug in -4 plus 4, you get 0, and then technically the 0 is being multiplied by the other -4 minus 4, so then it all equals 0 still. Is that right?
Yeah, it's very well thought out. I'm going to say it back to you just to make sure. 3 points for Gemma. She said, okay, I get it. If I plug in x equal exactly -4, not close, but exact, this will be 0. I say, fine. That gets multiplied by whatever this is. I don't really care what this is because once there's a 0, 0 times whatever would be 0. And you're right. Now I know that the whole thing is undefined because I don't know how to divide by 0. Does that help?
Yes.
Well done, Jim. 3 more. Oh, please, Henry.
So you could have done it just the same by doing where you did you analyze each one differently. So you do 4, you do x approaches 4 from the left, and then x approaches 4 from the right. So you could have done it like that, but you just combine them into one step.
Yes. So if you had done them separately, you'd get the exact same result. I was trying to save a little writing for you to say, oh, from experience, I can tell you that if you start with a single formula, about 99% of the time in this class, the left and right limits will be the same. There's a few exceptions, they're just not very common, so I'm still kind of being careful not to miss it if there is an exception, but you could do the same thing. 2 more. Please.
What happens when your first yellow box doesn't
Oh, gotcha.
if it has different?
Let's, so the only way you're going to get this yellow box is if we find a factor of the top being exactly the same as a factor of the bottom.
Right.
Okay. So we're going to do an example now to answer your question, Ava, of where that doesn't happen. Is that kind of what you're saying? Yes. Good work. 2 more. Anybody else? Okay, we'll call this one done. Stop the video.